Here's Group 2. Today, we will show you about electroplating in this video. The definition of electroplating. Electroplating is the process of depositing a thin layer of metal on the surface of a metal object. It is an electrochemical process that uses an electric current to reduce the contents of the desired material from a solution and coat a thin layer of metal on a conductive object. The deposited metal is called the plating or plate. The most commonly used metals for electroplating are copper, nickel, zinc, silver, and gold. The electroplating materials are usually applied in the form of an electrolyte solution containing metal salts, and then reformed into the metal from on the surface of the metal objects.
Okay, thanks for Mr. Chen's explanation. Now let's turn to electroplating process. From the picture, we can see that the anode side lose electron and cathode side got electron. Simply describe it as electron comes from anode and then go into the cathode. Moreover, we can see that anode is connected to the positive side of charge, while a cathode is connected to the negative one. The electrolyte in the electrolytic plating cell should contain positive ions of the metal to be deposited, like here is copper. These quotients are reduced at the cathode to the metal in the zero valence state. For example, the electrolyte for copper electroplating can be a solution of copper sulfate, which dissociates into copper 2 positive cations and SO2 minus 4 anions. At the cathode, the copper 2 positive is reduced to metallic copper by gaining 2 electrons. And here is the chemical formula. Like I just said before, anode size is oxidation and the cathode size is reduction. And overall reaction is anode size plus cathode size. The left electrode is made of a metal, which is more reactive than copper. The right electrode is copper. The solution contains both 2 ions from copper sulfate. At the copper electrode, the copper ions gain electrons and deposit as solid copper.
Okay, hello, Professor. My name is Zhu Minghao. Next comes my lecture contents. Okay, I will explain some basic knowledge about extrapolating through a topic. Okay, you can see this question examine the electroplating process below. Write the redox half reactions for the process. Okay, so we can see, first of all, we can see that the cadence in the electrolyte move towards the spoon. So it can be known that one side of the spoon is the cathode. The silver plate on the other side is the anode. So the electrolyte is AgNO3. The cathode is the spoon. It's also called metal to be plated. The reduction reaction is Ag plus then we will get Ag. So Ag plus in solution gains electrons at the cathode, forming a silver layer. And also the anode is a silver electrode. It's also called plated metal. The oxidation reaction is Ag. Then we will get Ag plus electron. The silver electrode at the anode loses electrons and dissolves as Ag plus into solution, replenishing the silver ions in the electrolyte. Okay, this is all I want to say. Thank you for listening.
Assalamu alaikum and good afternoon. This is Shifeng He from Group 2. Today I'm going to talk about applications and examples of electrical plating. First of all, it's exterior decorative parts like car components, such as door handles, emblems, and radiator grills. They often employ electrical plating processes, like chrome plating, to enhance metallic luster and texture, thereby to improve the vehicle's overall aesthetics and premium feel. The next is jewelry. Some jewelry, some imitation precious metal jewelry uses processes like gold plating or silver plating to achieve an appearance similar to gold or silver. They offer a relatively low price to meet customers' decorative needs. And the last is a printed circuit board, aka PCB. In the manufacturing printed circuit boards, copper electrical plating is used to thicken the circuit traces, ensuring excellent conductivity and stable signal transmission, and meeting the high performance requirements of electronic products. So that's basically all of the examples, and thanks.
Okay, let me do the summarize. The first is the electroplating definition. Electroplating is the electrochemical process made by electronic convert, where metal ions in a solution are gradually deposited onto a conductive substrate, forming a continuous metal coating. This endows the substrate with components like corrosion resistance, enhance wear resistance, or improve appearance. Common plating metals like copper endow substrates with conductivity, wear resistance. Electrochemical plating metals often metal solid electrolytes form coating on substrates via electronic current. Now, this is a Cooper plating experiment, and this is anode formula, and it is cathode formula. In my eyes, the Cooper plating experiment is like Cooper is transferred from the anode to the cathode, adhering to the surface of the metal to be plated to achieve electronic plating. The concentration of Cooper surface in the electrolyte remains almost unchanged. It is unchanged, which is equivalent to the anode Cooper dissolving and redepositing onto the cathode. The last one is the practical application. I give an example is the PCBs. PCBs serve as the nervous system of the electronic device, and the Cooper plating is the kernel manufacturing process. By planting Cooper on the substrate and wear, conductive threads are formed, ensures stable connection and signal transmission between electronic components. For instance, in the motherboard of smartphones and computers, the quality of Cooper plating dictates evidence single loss and latent uniform defect, where Cooper layer is calculated for high performance PCBs. Okay, this is my summary of electronic plating. Thank you.